Hey there, Year 11s. In this video, I want to go through how to sketch inverse functions. Now, there are two ways to do this. Let's have a look at question 3 of exercise 13G. They ask you to find the inverse function of each of the following, right? So normally you need to have an idea of what the function looks like, as in for the inverse, and then you can sketch the inverse, right? So this is what we normally do. Say we do 3A. Okay, so if we were to do 3A, you would say the function is given by 3 to the power of x plus 2, okay? If we were to quickly sketch this, okay, I'm just gonna grab my axes out and do a very rough sketch. So I know that the plus 2 tells me the graph shifts up by 2. So I know there's a, that's not good. I'm going to use a ruler. Here we go. There we go. Slightly off. Here we go. Plus 2. So here we go. There we go. Okay, so this is what your normal graph would look like. You've got up by 2. And it's a normal exponential graph, so when I draw it, it's likely to look something like this. Whoa, what happened there? Let's do it again, and there we go. That's my exponential graph, right? So that's my that's my f of x. So when you need to sketch an inverse function, often we feel like we need to find the equation, so figure out what does the inverse function look like, and then you can sketch it, right? You don't have to. There is a second method which you can do by using the one theory or the understanding of how do inverses work. In inverses, remember, it follows this transformation. Every xy coordinate, the x coordinate now becomes the y coordinate, and the y coordinate now becomes the x coordinate. Okay, so that x value is the same as the y, and the y is the same as the x. So in that transformation, we know a couple properties. We know that the domain of the function, so the original function, is equivalent to, and it swaps to, the range of the inverse. And same thing with the range of the function, it becomes the domain of the inverse. Now that's special because that means that whatever you currently have right now, because we've got f of x, right, sketched here, that means everything gets reversed. So instead of, say, for example, the asymptote being y equals 2, well, then that means the asymptote now will be at x equals 2. Can you see that? I'm going to draw x equals 2 here. X equals 2, say about here, just to keep it all quite symmetrical. I'm going to use another color. Let's do orange. Okay, so orange. This is my new one where it's x equals 2. So that's the asymptote for the inverse function. So I don't even know the inverse equation yet. Can you see? Now, another way to also figure out, well, how are the shapes going to look like? Remember I taught you to tilt your head. So if you tilted your head, let me see if I can, I'm going to screenshot this and I'm going to pretend that I'm tilting your head right now. Okay, I'm just going to paste it over here. Can you imagine trying to tilt your head? Why can't I rotate this? Oh, I actually thought I was able to rotate this shape. There's usually a... Oh, no, I can't. Well, that's not... I reckon there is in Word. I might be tangенting off right now, but let's just see if I can do this, okay? If it doesn't work, we'll go back to... I just don't want to draw too many lines to confuse you, that's all. I just wanted to get straight to the physical part of visualizing it. And it's proving to be quite tricky at the moment. Here we go. All right. So let's see if this shape, yeah, so this has the, all right, it's got that rotating shape. What I wanted you to do, if you tilt your head enough so that you can see it like this. Can you see that? So I like it like this, in this particular shape, because you see here, this, where's my pen? when you rotate your head enough so you can see it like this, when I asked you to draw it symmetrically, okay, so imagine there was a line that's coming down the center right now, then to draw the graph symmetrically, you would then say, oh, well, it'll have to look something like this, true, to make it symmetrical. If you tilt your head enough to see it that way, and then you tilt it back, that's your inverse function. What I've just drawn here, this is the inverse function. And this line is the line that we often call the y equals x line. Okay, so that's the y, that's the reflection, that's where the mirror is. So the graph flips over the y equals x line. So if I head back to this graph here, I'm trying to say to you that there's this, whoops, there's another line that goes like that. And if you can picture that inverse function, which I'll draw over here again, it's a reflection this way. So if you tilt your head, you can see that red line. If you tilt your head that you're facing that red line, you'll see that the shape is symmetrical across that line. That is the inverse function, which coincidentally, or not coincidentally, but is your inverse function, isn't it? That's your logarithmic function. True? Have a think about it. And so this is special here because when we go back to this graph here, you can simply figure out what the inverse function should look like without even finding the equation. See, we still don't know what the equation is, but I can almost predict that it's going to look something like this. If I were to draw it a bit more symmetrical, it may look more like that. Okay, so, and then how do you find the axis intercepts? Well, if you knew the first one over here, okay, which is the y-intercept, true? That's the only intercept that you got. Y-intercept for the function, so if f of x is 3 to the power of x plus 2, if you can find the y-intercept, which we know y-intercept is when x is equal to 0, so let x equal to 0, and you don't know what y is. So therefore, f of 0 is equal to 3 to the power of 0 plus 2. 1 plus 2 now equals to 3. So therefore, your y-intercept is at 0, 3. So that means over here, I now know this is 0, 3. And that's great because when we do the inverse, remember we said that you're swapping the x and you're swapping the y, or the x becomes the y and the y becomes the x. That means this point here has to be 3, 0. And there you go. I've actually got my inverse function without even actually finding the equation of the inverse. So that's the second method, and often in year 12 exams, they will give you not enough information to find this, but they expect you to be able to sketch that. And that's why I'm teaching this. Okay, so if you, the other method obviously is then to actually do the full-blown algebra to it, where you can try to find the inverse by actually letting xy become yx. So your equation, which started off as f of x equals to 3 to the power of x plus 2, we know that it will become x equals 3 to the y plus 2. And if you're wondering what I just did there, I'm just saying let f of x equal to y. So you normally have then y equals 3x plus 2, right? And then we know that through the transformation for an inverse function, the x becomes the y and the y becomes the x, and that's all I've done. So the y becomes the x and the x becomes the y. That's it, okay? And so from here, we're solving our equation. We're like, okay, minus 2 on both sides. Remove the base 3, because that's exponential base 3. Then the inverse is logarithmic. So remember, to find out, to solve this, we're going to do log base 3 of both sides. And that now gives me the next line as log base 3 of x minus 2. And then log base 3 of 3 to the power of y. We know that these are inverses one another, so they will cancel out. And then you get y is equal to log base 3 of x minus 2. Okay, so this is my inverse. This is now, therefore, inverse is equal to the log base 3 of x minus 2. And if we were to sketch this, you see, if we were to sketch this graph, you can see x minus 2 tells me I'm moving to the right by 2. and logarithmic graph is all positive and all that. So right by 2 means asymptote is going to be at x equals 2, and that's my normal logarithmic graph. And then obviously you have to find the x-intercept. But you see, doing all that, you didn't have to go through all that process. You could have just directly gone and sketched it from knowing the first equation. Okay, once you can visualize the first one. So let's try another one. Okay, let's try, where is it? Oh, there we go. Question 3. Let's try a B. Let's do B. Okay, let's do B. So B is now f of x is equal to log base 2 of x minus 3, right? So if I were to sketch this, this is what I would do. I'd do a really rough sketch over here. So here we go. We're gonna, I should make them all background actually, and then that avoids that problem. But anyways, here we go. So again, x minus 3, we know this is going to move to the right by 2. And that means the asymptote now, if it's gonna, not by 2, by 3. So the asymptote is a vertical asymptote. Here we go. And I'm gonna say this is at x equals 3. Remember it's x, not y. And logarithmic graph looks pretty simple there. There's no negative, so it's the same shape as it should be. That's my f of x function. You do need to find the, in this case, the x-intercept, which is this point. So to find the x-intercept, again, we know that y must equal to 0. So here we go, 0 is equal to the log base 2, 2 of x minus 3. And again, how do you solve this? Get rid of that log base 2 by doing the inverse. And what's the inverse of log base 2? It is 2 to the power of whatever the right-hand side is, and then 2 to the power of whatever's on the left-hand side. Yeah, because that's logarithmic base 2. Inverse of it is exponential base 2. So this now gives you 2 to the power of 0 is equal to 2 to the power of log base 2 of x minus 3. Inverses of one another. Ooh, what happened there? 2 to the power of log base 2 cancels out, and so then you get x minus 3 is equal to 2 to the power of 0. That's 1, x minus 3, x equals to 4. Okay, so that tells me that when x is 4, the y-coordinate is 0. So now I know this is 4, 0. Now, to find the inverse, if I were to sketch the inverse, I don't have to actually solve for the equation. I can actually use what I currently have and then figure it out. So remember, everything reverses itself, right? So that means if x equals 0 is the asymptote for the function, then for the inverse, it would have to then be y equals, I'm going to do another color. Let's do orange this time again. So I'm going to do orange. There we go. And we know that this, instead of x equals 3, it is now y equals 3. So instead of vertical line, it becomes a horizontal line. And then an exponential graph normally is like this shape, true? And it's the same thing. If you didn't know that, you can still tilt your head again. Try to remember that line I was telling you. Imagine there was a mirror here. Tilt your head and try to draw it so it's symmetrical to what you see, right? And what I'm seeing here is that it will cross. I'm going to do a green line just to help you visualize here. It seems like the asymptote is the horizontal line y equals 3. And if it helps you as well, maybe draw in the y-intercept, because you've got 4, 0. Well, then the y-intercept now would be 0, 4. So maybe here. So that's 0, 4. So if you picture it now, can you kind of see it's going to look something like that? Can you see that? If you tilt your head, I'm just trying to make it symmetrical right now. So this is your inverse function without actually finding the equation, unless they ask me to. But if they just want me to sketch, I just needed to know what the function looks like, and I can mostly predict or sketch what the inverse function should look like. So that's my inverse function there. Okay, and you can do the same for C and D and onwards, but they're just flicking between exponential into a log graph. That's what the inverse would be, and the log graph becomes an exponential, right? That's what I want you to practice there. So if you've got more questions, post them into Padlet and I'll do more of these, but I hope this video gives you a better idea of how to find the inverse function in sketching simply from the function, the original function itself. Okay?